Greetings everyone, welcome to the third and final video for section 4.6. Just one more type of example we'd like to go over here. Okay, so we're going to talk about Newton's law of cooling, which is something that helps us to determine the temperature of an object cooling in a particular environment after a certain amount of time. So here's how it works. So the temperature of an object T and surrounding air with temperature T sub S. So this T sub S here is the temperature of the surrounding air. Will behave according to the formula T of T equals A times E to the K times T plus T sub S, where in this formula T is time and the units of time will depend on the units of time in our problem. A is some constant that's determined by the initial temperature of the object. So notice it's not the initial temperature, it's something determined by the initial temperature. And then K is another constant, which is the continuous rate of cooling. The other thing I want us to notice is E here in this problem is that number E. So remember Euler's number. And hopefully that makes sense because here we see that we're talking about a continuous rate of cooling and things do cool continuously. So that helps us to see that that should be the number E. All right, so let's apply this to a problem. So our really good friend, Beyonce, she really likes to work in the kitchen. You can see from the picture up there how happy it makes her. So to thank them for her contributions to her Baychella performance, which is the one on Homecoming, which if you haven't seen that, well, I don't know what you've been doing with your time. Queen Bey has decided to bake cupcakes for all of her dancers. When she takes the cupcakes out of the oven, they have an internal temperature of 165 degrees Fahrenheit. She places them on the counter of her kitchen, where the temperature is a comfortable 68 degrees Fahrenheit. And then after 30 minutes, she checks the cupcakes and finds that they have cooled to an internal temperature of 140 degrees. Okay, and so what we're supposed to do first is find the formula for that function T of T. So we need to basically work with this, the A times E to the K times T plus T sub S, and find all the missing information here. So that means we need to find the values for A, K, and T sub S. Everything else will stay for now. All right, the first one we can figure, hopefully you see, is that value for T sub S, because remember that is the temperature of the surrounding environment. And so the cupcakes, once they're taken out of the oven, they're put in an environment where the temperature is 68 degrees Fahrenheit. So we know that T sub S should be a plus 68. And so now we're on our way to finding the rest of the equation. And then notice that the other pieces of information were given. So when she takes them out of the oven, they have an internal temperature of 165 degrees Fahrenheit. Which means at time 0, right, because that's when they come right out of the oven, the temperature is 165. So that would be kind of our starting point. We're also told that after 30 minutes, the temperature is 140 degrees. So 30 minutes and 140 would be another point. And we can use these to find the values for A and K. So let's start by plugging in the values 0, 165, or the point I should say. So when we do that, we should have 165, since that's our output, equals A times E to the K, since we don't know K yet, times 0, because that's the value for T, plus 68. Notice that what we get here with this E to the K times 0, well, K times 0 is 0, so this becomes E to the 0, which is just 1. So this is really saying A times 1 here, but we know A times 1 just gives us A. So our equation then is looking like 165 equals A plus 68. And we can solve for A by subtracting 68 from both sides. And so when we do that, it looks like we get A equals 165 minus 68, I believe is 97, is that right? Yeah, it is. All right, good. So now we have the value for A. So we can put that into our equation over here. Okay, and then we need to use our other point now to solve for the value of K. So we plug that point in now, so we'd have 140 equals 97 times e to the k times 30 plus 68. And we'll solve for k. So I'm not going to do all the steps for that right now. You can pause the video and do those yourself. But I'm doing them out on my calculator right now. And I believe what we get, if I do that, is negative 0.0099. Okay, so we have the value for k now. So now we can write out our whole final version of our equations. We know a is 97, k is negative 0.0099. You might even use more decimal places than what I use, just to maintain accuracy. So it becomes e to the negative 0.0099 plus 68. And whoops, I forgot the t here. So the function is t of t equals 97 times e to the negative 0.0099t plus 68. So now we use this in the second part of this problem, which tells us to use our answer from above to figure out how long it will take the cupcakes to cool to a temperature of 90 degrees and therefore be ready to be eaten. So again, we're trying to figure out how long, and we're given a temperature. So we set this up just kind of like we did the last one. So this would be 90 equals 97 times e to negative 0.0099t plus 68. We can use our techniques of solving exponential equations to find the value of t. So you could again pause the video at this point and figure it out for yourself. All right, and working this out myself, I get that the value for t here equals 149.866. In this case, we're talking about minutes, of course. So it'll take 149.866 minutes, which is, what is that, about 2.5 hours for the cupcakes to be ready to eat. Now, if that was me, I'm not sure I could wait that long to eat them. All right, that's all we have for now. Thank you so much for watching.